a question given under the square root something. You remember? Have you all done? Hello? What is the sum we did at last? Bless and tell the sum. Can you tell the sum, please? Yes? I don't remember the question. That's what I'm asking. One of others, Vidusana, can you tell the sum, please, at last? Vidusana?
Yes, sir.
Ah, yes. So, what is the sum I gave at last?
0.275 into
0.27
5 into
275 into
root of 19
square root of 19
over
90.
root of 19.
Is it clear? Right, upon
root of 0.00873.
square root of 0.00873. Is that the sum? Right.
Yes, sir.
Okay, thank you. Right. So here you can use that formation, let's say, even if it is x or any term you can use for that, whatever it is given. Right. So consideration of logarithms. So log x equal to log 0.275. Straight away you can write them in index form or scientific notation. This can be. So this one 2.75 into 10 to the power 1 place back sort -1 into this one square root of 19, that is 1.9 to the into 10 to the power 1, that's 19, but as it is square root, this is index half. Then upon this one also square root, but scientific notation 8.73 to the power, into 10 to the power. Some places move to the right, that means 3 places, therefore it's -3, right? Then to the power half, right? When you consider logarithms, separate logarithms, logarithm of 2.75 into 10 to the power -1 clear. These two. Then into means here plus logarithm of 1.9 into 10 to the power 1. At that end, this half comes in front. Then when it is division minus logarithms, here also half comes in front. So half of logarithm of 8.73 into 10 to the power -3. So this is expansion. Then as it is 10 to the power -1, when finding logarithms, you use bar 1 point, right? Bar 1 point. When you find the logarithm of 2.75 from your log table, I think you all have done it, right? 2.75 means answer 4393. 4393 plus half of 10 to the power 1. Therefore, 1 point. Logarithm of 1.9. Logarithm of 1.9 is 0.2788 minus half of, then 10 to the power -3. Therefore, it's bar 3 point. Now 8.73, logarithm of 8.73, that answer is 9410. 9410, right? We have to simplify. Here you see bar values, then division of logarithmic values and bar values there, right? You can write down bar 1.4393 plus you have to divide it by 2, therefore 0.6394 minus, when you divide bar 3.9410 by 2, you know that already we have done that division. Bar 3.9410 means you have to divide by 2, but it's not a multiple of 2 completely. Therefore, we have to make it as a multiple of 2. Therefore, you can give bar 1 to this and you can take plus 1 from that. Then bar 3, bar 1 becomes bar 4. Out of bar 4, 2 is bar 2 times. This is over. Then by taking this one, this becomes 19. Out of 92 is 9 times. 18, 1 remaining. 14, then 7. No remainder. Out of 1, it is 0. But out of 10, 5. So this answer bar 2.9705 when you divide it. Right? That answer clear. Now, sum of these two and subtract. And so when you add these two, 3 plus 4, 7, 9 plus 9, 18, 1, 4 plus 3, 7, 4 plus 6, 10, 1 remaining. That one is plus 1. So plus 1 bar 1 is 0. Minus bar 2.9705. Again, this answer will be 7 minus 5 is 2. 8 minus 0 is 8. 7 minus 7 0. 0 minus 9 cannot be. So you take 1 here by giving bar 1 there. Right? From this 0 minus 9 cannot be. Therefore, we take 1 and giving bar 1 to balance it. So now it is 10. 10 minus 9 is 1. Now it's bar 1. Bar 1 minus bar 2. Bar 1 minus bar 2 is, you see now, bar 1 minus bar 2. That means this is plus 2 minus 1. Finally plus 1. So this is 1.1082. When you check it again, by adding these two, you can have this also. Right, okay. Then this answer clear. Therefore, now still it is log x. Shall I write some? Right? This one log x. So x will be equal to, this is log x. X is equal to anti-log of 1.1082. Finally, you answer. This one becomes 10 to the power 1 into anti-logarithm of 1082. 1082, when you find it, 1082. Yeah. Then that answer is 1.283. 1.283. So finally, your answer will be one place. So 12.83. Right? I think it will be your answer. Or if there's any differences, you can talk. Right. Okay. Now we can apply this kind of words in sentence type questions, especially in volume and total surface area of solids. You will learn these things in lesson number 4 and 5 in your syllabus. So here, 4 and 5 you can do. Now in that, earlier in grade 10 you have studied the total surface area and volume of a cylinder. So at that time, by substituting this kind of values, if there is a cylinder with radius in decimal or height in decimals, then how we are going to apply them? Let's do one question connecting them, right? Now you know the formula for finding the total surface area. Let's say if the radius of the base is r and the height is h of a cylinder, then total surface area will be 2 pi r squared. Pi r squared is the area of one cross section, but two circular cross sections there in a cylinder. Therefore, pi r squared 2 times. Plus the curved surface area is 2 pi r h. 2 pi r h. This is the formula for that, but in short, you can have 2 pi r is common factor. Then here r remains plus 2 pi r common factor h here. So this is the total surface area of a cylinder of base radius r and height h. And the volume of the cylinder with the same measurements is pi r squared h. Usually, the area of the cross section into height. Area of cross section into height. So in this case, if some values are given for R and H, because pi already you know, right? So let's have a question. Now you can take it down. Find the volume of a cylinder of base radius 0.07 meters, 0.07 meters, and height 15 centimeters, and the height 15 centimeters. Pi is used here as 3.1428. But it's not needed. Right? You try to apply this. Formula is there. Volume is equal to pi r squared h. Directly you can use it. As the genetic information you get the DNA structure, double helix structure with kind of their double helix structure. Here, when you substitute base radius 0.07 meters and height 15 centimeters. So if you convert this, so same units will be used here. So two things you can do. One, here already 15 centimeters there. Therefore, you can make this radius in centimeters. If not, radius is given in meters, so you can make height in meters also. Right. So let's use height in meters. So centimeter to meter, you have to divide by 100. If you divide by 100, two decimal places will be there. Therefore, this is 0.15 pi r squared h. Then you had used logarithmic rules here. So answer log 3.142 plus 2 comes in front, 2 times log 0.07, at that time this will be 7.0 into 10 to the power 2 places, therefore negative 2. Again plus logarithm of this is 1.5 into 10 to the power negative 1. Right? So this answer, logarithmic values, you can find from the table 3.142. 4972, 0.4972. Here 2 times negative 2 becomes bar 2 point, log 7.0 is 8451. 8451 plus this answer 10 to the power negative 1 becomes bar 1 point. Logarithm of 1.5 is 1761. 1761. These are the logarithmic answers, right? Then you have to multiply this. So 0.4972 plus 2 into 1, 2, 2 into 5, 10, 1 remaining, 2 into 5, 8 plus 1, 9, 2 into 8, 16, 1 remaining, 2 into bar 2 is bar 4, plus 1 is bar 3, plus bar 1.1761, all together you have to add. So all these three values you can add, 2 plus 2, 4 plus 1, 5, 7 plus 0, 7 plus 6, 13, 1 remaining, 9 plus 1, 10, plus 9, 19, plus 7, 26, 2 remaining, 4 plus 2, 6, plus 6, 12, 12 plus 1, 13, 1 remaining. That plus 1 and bar 1 cancels, therefore this bar 3 will be there. Is it correct? Right? 2, 4, 5, 7, plus 6, 13, 1, then 10, 19, 7, 26, 2 remaining, then 6 plus 6, 12, 12 plus 1, 13, 1 remaining, that 1 and bar 1 cancels, so bar 3 remains. So this is what log V. So V becomes anti-log of bar 3.3635. So this answer is 10, bar 3 becomes 10 to the power negative 3 into 3635, the logarithmic, sorry, anti-logarithm of 3635. 3635 will be 2.309. 2.309. 2.309. So when you convert this number in ordinary form, this is in scientific, 10 to the power negative 3, that means 0.002309. Right? That means the decimal point was here, 3 places, 0.002309. The unit is now cubic meter because we use the units in meters, cubic meters. Right? So if you convert this answer in cubic centimeters, if you convert this answer in cubic centimeters, you know 1 cubic meter is equal to how many cubic centimeters? You know, when you take 1 cubic meter, that means 100 centimeter into 100 centimeter into 100 centimeter. Finally, this is 1 million cubic centimeters. 100 into 100 into 100. 6 zeros there. So this is simply 10 to the power 6. 10 to the power 6. That means if you want to convert this cubic meter into cubic centimeter, you have to move the decimal point. How many places? 6 places to right. So 2, 4, 6. So straight away you can write 2309 cubic centimeters like that. But no matter, you can keep this answer in the same mode also. Right. Then if you are asked to express the answer in cubic centimeters, then you can convert it. Right. Now we are practicing enough questions using bar values. Using bar values. So how we are going to apply the logarithmic rules with different types of values. You know, basic logarithmic rules, you know, formation of logarithm very clear. Later, you know, logarithm of whatever the base, logarithm of x to the base x is equal to 1. That means logarithm of any value with the same base is 1, but some conditions there, you know, the base. Then even if it is logarithm of mn, if that's a product of two values and the logarithm of that using the logarithmic rule, that means using the index rule we formed it. Therefore logarithm of m to the base a will be plus logarithm of n to the base a, as well as logarithm of m upon n to the base a will be logarithm of m to the base a minus logarithm of n to the base a. Furthermore, if there's an index, let's say now logarithm of m to the power n to the base a, this also n becomes in front, so n times logarithm of m to the base a, like that. Already we have used these things when simplifying numbers using logarithmic tables. But here we are going to have some simplifications using these logarithmic formats, and through them we are going to make some logarithmic equations also. Then we are going to find the solution of them, right? Okay. So first we do some questions now. Simplify. Simplification. Logarithm of 27 to the base 3. Number 1. Number 2. Logarithm of 1000 to the power 1/3. We call this is cubic root, but in index form, that is 1000 to the power 1/3. Index 1/3. Number 3. Log 4 plus log 25 minus log 10. Using the logarithmic table, you can simplify and find the value. This is LG. A base 10. Right. Number 4. Log 16 to the base 2 upon log 2 to the base 2. Number 5. You try to simplify these questions using basic logarithmic rules. You know, simplifying this is first you have to make 27 as the power of this base 3. Then conditions. By use of Irvina bacteria. By use of Irvina bacteria. Six questions given. Last, log 4 upon log square root of 2. Right? Yes, the base is A. Different base. Log 4 to the base A upon log square root of 2 to the base A. Right. Shall we check the answer now? Log 27, number 1. Log 27 to the base 3 is log base 3 here. 27 is 3 to the power 3. So this 3 comes in front. So 3 times log 3 to the base 3. This answer is 1. 1 into 3 is 3. First answer. Second one. Logarithm of 1000 to the power 1/3 to the base 10. But you know, this 1000 here, that logarithm with the base 10, therefore straight away you can use this log. 1000 is 10 to the power 3 to the power 1/3. This is index rule, right? So 1000 is 10 to the power 3 to the power 1/3. You know the power of, that means index of index can be multiplied. When these two values are multiplied, 3 into 1/3 means these 3 cancel. So it will be log 10. Log 10 is only 1 because of base 10. Right. Third one, logarithm of 4 plus logarithm of 25. You know the reverse use of logarithmic conditions. That means if they are multiplying, we have to add them, then conversely. So addition of logarithm becomes multiplication of those two numbers. Log 4 into 25 minus becomes division by 10. You know, 4 into 25, 100. 100 by 10 is 10. That's log 10. Still the answer is 1. Number 4. Logarithm of 16 to the base 2. So this can be expressed as a power of 2. So logarithm of 16 base 2. 16 is 2 to the power 4 upon log 2 to the base 2. So this answer 4 comes in front. 4 times log 2 to the base 2 upon log 2 to the base 2. These two cancels. So this answer is 4. Answer 4. Next one. Number 5. Logarithm of 0.81. Again logarithmic rule. Logarithm of 0.81 plus therefore into 100 to the base 3. Now you know this answer. Multiplying by 100 means 2 places back. Therefore this is log 81. 81 to the base 3. Now you know 81 is 3 to the power 4. So log 3 to the power 4 to the base 3. This 4 comes in front. This is 1. Therefore still that answer is 4. Right? Last one. Do it here. Right? Last one. Number 6. Log 4 to the base 8 upon log square root of 2 to the base 8. As we did here, if we have these two values equal, you can remove them, then number will be there. But here, how to make it? So, you have to make this number 4 with the help of this. You know, number 4 is equal to simply 2 to the power 2. This 2 is equal to square root of 2 to the power 2, is it? This one. Square root of 2 to the power 2 is equal to 2. This much 2. 2 to the power 2, 4. So instead of 4, you can use this. So finally, this is square root of 2 to the power 4. square root of 2 to the power 4. Right. So with the help of that, you can write log 4 means square root of 2 to the power 4 to the base a upon log square root of 2 to the base a. So this 4 comes in front, these two values same. Therefore, final answer is 4. Final answer is 4. Check your answers. Some more exercises. Number 6 there. Then we continue from 7. 2 log 5 plus log 36 minus log 9. Log 9. 2 log 5 plus log 36 minus log 9. Number 8. Log 7 by 11 plus log 220 by 40. Continue the sums. Number 9. Log 7 upon 8 plus log 6 upon 7 plus log 4 upon 3. Number 10. One 25 by 23 plus log 24 by 6 minus log 5 by 23. Question number 9. Log 7 upon 8. This answer is log 7 upon 8 plus log 6 upon 7 plus log 4 upon 3. If you're not clear, then you can ask. Right. First one, Pranavan, can you tell the answer for the number 1 question? Pranavan, tell the answer for the first one. What is the answer?
2.
2. Right. Okay, let's take. Now these 2 becomes the power of 5. Then 5 to the power 2, that will be 25. Okay. So this one logarithm of, when you take the common logarithm, then rule will be reversed. Then this 2 will be here, 5 to the power 2. 5 to the power 2 is 25. When it is addition, conversely, this is multiplication, 36. Then minus makes division by 9. So 9 and 36 can be cut 4 times. 25 into 4 is 100. 100 means that's 10 to the power 2. Right? Then 2 comes in front. Log 10 is 1. Therefore, final answer 2. Then second one. Second answer, who can tell the answer? Aksha, second answer.
1, sir.
1. Okay, let's take logarithm of, you don't feel about this fraction straight away. These two values added, therefore, in logarithm 7 by 11 into 220 by 14. You can make it. So 7 into 1, 7 into 2, 11 into 1, 11 into 2, 22, this 0. So 20 by 2 is 10. This one. So log 10 is equal to 1. Next one is also the same. Therefore, logarithm of 7 by 8 into 6 by 7 into 4 by 3. This answer. 7, 1 times 1 times cancel. Then 3 into 1, 3 into 2. 2 into 4, 8. This 8 cancel. Finally, 1 is the answer. Log 1. How much is this? Log 1. Tenu Harsan, what is the answer for this? Log 1 is how much? Tenu Harsan, answer please. What's the value of log 1? Unmute and answer. Tenu Harsan, what is the answer? You already do it. Vidusana, what is the answer? Vidusana, tell the answer for this. How much is log 1? Vidusana, are you there? What is the answer?
1.
Log 1. Is it okay? Log 1? What is the answer for log 1?
Sir, 0.
0 is the answer. Log 1 with any base is 0. Log 1 with any base is 0. Right. Okay. 0 is the correct answer. Okay. Next one. Number 10. Logarithm. Here logarithm. So I'll ask question from someone. Sivadarsan, what is the answer? Sivadarsan, what is the answer? Have you got? Or else Pungundran, tell the answer for this. Even if you complete, unmute and answer please. Right, let's check. Log 125 by 23 here, plus multiplication here 24 by 6, minus makes it division. So this division becomes multiplication when you take its reciprocal, So you can use this minus becomes division here. Then if you use the reciprocal 23 by 5, that will be multiplied there. So answer. Here 5 into 1, 5 into 25. 23 ones here, 23 ones. 6 into 1, 6 into 4. 25 into 4 is 100. Already you have that value. Log 100. 100 means 10 to the power 2. 2 comes in front. Finally, answer is 2. Final answer is 2 for this question. Right. Next, after this simplification, we are going to solve some equations which are given in logarithmic form. So, our next subtopic is logarithmic equation. Logarithmic equations. Right. A logarithm formation with equal symbol. Right. For example, when you have this, let's say LG means based and no problem. Logarithm of x plus logarithm of 5 is equal to logarithm of 15 minus logarithm of 3. All these logarithms are base 10 logarithms. Right. So here in both sides of this equation we have logarithms. So we can simplify. First we can simplify both the sides to single terms using conditions. Right, this one log additions of product of values x into 5 is equal to here also logarithm of 15 minus, therefore 15 is divided by 3. In the previous simplifications, we make logarithms. We made logarithms. Like that here, we can remove logarithms. That means if you take anti-logarithm on both sides, because you know, in equation, we do the same activity on both sides, same actions on both sides. Therefore, if you take anti-logarithm on both sides of this equation, then anti-logarithm of logarithm will be cancelled. That means removal of logarithms happen. So simply this is 5x is equal to 15 by 3 is 5. So 5x is equal to 5. Therefore, x is equal to 1 like that. From the logarithmic form of equation, you can bring it in numerical form. So then from the numerical equation, solution is will be very clear. Right? Number 1, you try to solve this. Right, here's an equation. Log 2 to the base 5 plus log 2x to the base 5 minus log 3 to the base 5. That's equal to log 4 to the base 5. Right. You try to solve these two equations using logarithmic conditions. Tomorrow we will have more questions on this, and later we can move on indices. Actually, this logarithm started with indices. So indices and logarithm was the lesson. Now we have studied in that uses of logarithms here. Then hereafter we are going to move on indices. Here in your syllabus, indices with rational indices, right? So if the indices are in fraction form, how we are going to simplify? right? Tomorrow we will do that question. So here you can do these two questions today. Okay. Until then, have a nice day, children.